last lecture, I have given the introduction to the classes, object, and the different characteristics of OOP language, that is data encapsulation, abstraction, and data hiding, then inheritance and the polymorphism. All we discuss all this with example, right? Now we'll have the next thing is benefits of OOP. So what are the different benefits of OOP, object oriented programming? It's a modularity for easier troubleshooting. Then the reuse of the code, we can reuse the code. Then flexibility through the polymorphism. So we can have the only one function and we can use that one function for the different kinds of data types, right? Then we have the effective problem solving mechanism. Then again, because of the classes concept and different access specifiers, we can have the security also. Then next is code maintenance. Code maintenance is easy in OOP. Next is through inheritance, we can eliminate the redundant code and extend the use of existing code by using the inheritance concept. Then data hiding helps the programmer to build a secure program that cannot be invaded by code in other parts of the program. So one of this characteristic make the famous for the OP concepts later on after the procedural oriented concept. Okay, then it is next, it is possible to have multiple instances of an object and they can coexist without any interferences with each other because every object data and the methods are allocated differently. Then it is possible to map objects in the problem domain to those objects in the program. So mapping or the message transfer also can be possible within the object oriented programming language. Then easy to partition the work in a project based on the object because we can module the real time entities into the classes and the objects, the related functions we can use to manipulate that data. So this is what the project based on the object dependent we can use for the OOP. So these are all discuss the benefits of OOP, right? Then next is the actual language, which is the object oriented programming language C++ we are going to discuss. So C++ is a middle level programming language developed by Journey Stronstrup starting in 1979 at the Bell's Lab in USA. So it is like in early 80s we can say this is invented. So initially the named was C with classes. So initial name was C with classes. The features of C++ were a combination of the object-oriented features of a language called Simula 67 and the power and the elegance of the C language. Therefore, the C++ is an extension of C with a major addition of the class construct features which came from the Simula 67 language. Simula 67 language is the OOP language at that time. So Journey Stronstrup, what he did, he just take the concepts from the C language as well as he take the concepts from the Simula 67, which is a OP based language, and it combined together with the power and elegance of C plus the Simula 67 language. Combination of this became the C with classes or C++ language, right? So C++ basically runs on a variety of platforms such as Windows, Mac OS, and the various version of Unix as well. Right. So this is a variety of platform can be supported for C++. Also, C++ is a superset of C programming with additional implementation of OOP concept as I already told. The this plus plus is nothing but the increment towards the C language. Increment towards the C language, or we can say the increment operator, if you remember that C language is having the increment operator. So this is an increment towards the C language. Okay. So next is C++ is called as an object-oriented programming language because this is views as a problem in terms of object involved rather than the procedure for doing or handling it. So we are actually writing a class, and then we are having different type of methods which can handle that data inside that particular class. So instead of writing the methods, we are concentrating on the objects to handle the data part. Okay, so everything is in form of the data as well as objects. So object oriented programming is always good for the writing large business logics or the large applications or the games or different types of applications, as well as real time application systems, or as well as editors, compilers, databases, communication systems, and any type of the example we can have for the application of C++ language. So OOP is also very much desired for the maintenance as well as for the long term support. So next is how we can have the C++ program structure. So initially, as everything has having the header file declaration section is there. Okay, so header file related which is going to be used in our code, we are going to write it first. Header file, just like we include the IO stream, so that is the first section, then followed with the global declaration section. If we have any type of global variables or static variables which we are going to use in your program, then we can declare it afterwards, the header file declaration. Then next is the declaration of the class declare, as well as the structure of that class is having the member function and the data members. So it includes the data members and the member function for that class. Okay, so it is up to you whether you are going to define that methods inside the class or outside the class. Okay, so that is the class declaration and their method definition. And then followed with that main method, main function. We call the main function. Why we call this main function? Because execution starts with the main function. So main function is the starting point for our program. So we write the main function over there. Okay, so if apart from that any method definition we require, then we can write the methods into the next section. This is the structure of the C++ program. Okay. The next is our C++ basics. As we have already discussed in namespace standard, we are using after IO stream. We have to include the using namespace standard. Okay. Then class example. This just a class name example, then their declaration part by using the its member variable and the member function. Then we have here calling function, that is the main int main, and the code to access is that function. Okay, so this is the structure how we can write the our class example. Now we have the C++ data types. So we have a user defined data types we can use here, just like in C language, right? Fundamental built-in data types and the derived data types. These are the three data types which we are going to use in C++. So the user defined data types means this is a collection of actually fundamental built-in data types. Okay, so structure, unions, class, enumerations. These are all the user defined data types. Then the fundamental built-in data types are integer types, that Again, integral types means integer and character. Then we have the floating types, the float and double. And if you don't want any type of the data type, then we can write the void. Okay, so these are the fundamental building data types. And then the derived data types. What are the derived data types here? Derived data types means it's a collection of the fundamental data types like arrays, function pointers, and reference. These are the derived data types. Okay, so we are going to use all this. So more about the built-in data types, we must know what are the different type size and the ranges for this data type, basic data types. So character is in size, it occupies for memory 1 byte and the range goes from minus 127 to 127 for the signed character, and for unsigned character it goes to the 0 to 255. Okay, so then the integer type, it having the for integer, actually it will occupy 4 bytes in memory and range is given according to this. It occupies the ranges starting with minus to the plus. Again in unsigned int, size is 4 and it goes to 0 to this much is range 4 to 9496 7 to 95. Then short int again 2 bytes and minus 32768 to 32767 plus. Unsigned short int again 2 bytes but it goes from positive, so 0 to 65535. Then long integer again 4 bytes minus 2147483648 plus 2147483647. Similarly, unsigned long int 4 bytes 024294967295. Okay, so this is for float 4 bytes and for double it is 8 bytes. So similarly, the ranges are given minus 3.42 and up to the 7 digits it is allowing exponential. Okay, so floating points. How to declare the variable in C++? A variable defines what is a variable. A variable defines a location in the memory that holds a value which can be modified later on, or we can put up the value later on. Okay, after execution is over. So syntax for a variable, whatever the type, data type, and the variable list or variable name. In the above syntax, type refer to any one of the C++ data type. Okay, so declaring the variable in C++ should be declared before they are used in the hash include iostream.h. Earlierly we were using the iostream.h, but nowadays we don't use the .h. Directly we can write the iostream. So hash include iostream, this is required for the input output related class or object. Okay, so this is void main started with the opening simple kind of code. This one just print a value. Okay, so here integer n is equal to 10 and we are using the cout. This is a object of class OStream. Object of class OStream. Okay, so what the cout will perform? What cout will perform? Cout the value whatever the written on the right of this will be printed on your output device. Integer value is, now here the n value is written as 10, so it will print 10. Cout is used to display the integer value is 10, so writing here over integer value is 10, it will be the output. So n is declared as an integer type. You can mention it whatever you want to declare it. Simple example to show the use of the variable. Then rules for naming variables in C++. Always the first character of a variable must be a letter or a underscore. The variable name cannot start with a digit. Other characters should be either letters, digits, or the underscores. There is no limit for the length of the variable. Declared keywords cannot be used as a variable name. Declared keywords or the reserved keywords cannot be used as a variable name. That is a rule. Upper and lowercase letters are distinct for the C++ language. Then a scope of a region of the program, and broadly speaking there are three places in our program, overall program. Variables can be declared either inside a function or a block, which is called local variable. In the this local variables, its scope is only to that function, towards only inside that function or inside that method only. Out of that method nobody knows that variable. So next is in the definition of the function parameter, which is called formal parameters. In the definition of function parameters, which is called the formal parameters, outside of all functions, which is called global variables. Okay, so the local variables are only knowing towards this only one function. Inside that function its scope is also local, but global variables can be accessible overall where whenever we want to access it throughout any class or any method we can access. That is called the global scope. So parameters and variable declared inside this as the function are local. They only exist inside function part, and returns the variable no longer exists once the function returns value of that variable. So example using the local variables, hash include IOStream. The local variable declaration is for the main method int a comma b int c. So actual initialization a is equal to 10, b is equal to 20, c is equal to a plus b, and we are putting the value of c for the outputting through the object cout. Okay, so this cout operator, this operator is which operator? Bitwise left shift operator in C is called the insertion or put to operator. Okay, so return 0. This is what the IO stream. So here what you are using the A, B, C. These are all local variable declared, and we are actually using this towards the main function, and scope is only towards this opening and closing brace. Once it is closed, the scope is also closed for these variables. Then the global variables, we can declare the variable outside of any function definition. These variables are global variables. Any function can access or change that global variables. And we can use that for the debugging information or the using the count variables. Global variable, how we can use in program. So outside of main function you have to need to write this, as we have discussed that after the hash include part we can write that, declare that global variable, and we can access that global variable. Okay, so global variable is G in this case, and this can be accessed or its scope remains there after closing this one also. Then constants refer to the fixed value that the program may not alter. So defining constants, this is like defining the hash include values. Similarly, hash include we can use along with the stream using the hash defined preprocessor. So using at starting of the program, you can use the defining constant using hash defined preprocessor directive. Similarly, you can define the constant using the const keyword. These are the two ways how we can define the constants in our program. So hash define preprocessor. This is a hash define things are has to be pre-processed by the preprocessor. So preprocessor is going to firstly check whether that hash defined values are given. If it is given, this preprocessor directive will mention all this value in your convert into the program. Okay, before going for the compilation process. So this is the hash define identifier value. So hash define length 10, you are defining hash define width value 5, hash define new line slash n. This all you are going to declare this initially, and when once the program uses these values, that has to be changed with this numbers values whatever you have defined with the other value. So here length 10 and width 5 you have defined. So integer in main function integer area is equal to length into width. So in this case length value 10 and the width value is 5. This will be multiplied and the given value is put up into the variable area. Area will now printed over with the help of cout, and then there is again one more thing printed, that is a new line. New line is given by slash n over converted by slash n this value, and it will be giving the value, that is result is 50, and coming to the next line because new line is again printed over. This is what before the compilation process, this preprocessor directive will change these values, and then the compilation process happened. Similarly, const variable. Const is used, const prefix to declare the constant with a specific type, as this can be used over here. So this const type variable is equal to value. So example is hash include iostream, integer main, constant length is equal to 10. Similarly, constant width is equal to 5. So actually you are giving that everybody the values to be become the constant values, and your user is not providing the value for the variable length and width because this becomes the constant values as you are putting the keyword const in front of that variable. So this becomes the constant values throughout the program. Okay, so similarly next you are doing the same task. You are taking one more variable which is a normal variable integer type, and area is equal to length multiplied by width. So again your cout area is equal to, the output becomes 50. Output is 50 as the multiplication is the same, and the cout the next line is new line. So new line is slash n, as we have mentioned this one also here in const character new line, but your data type is here character because slash n is a character value, so it is taking as a character value, right? So next is the reference variable. As you know, what is the reference variable? Reference variable, simple variable you know, constant variable you know. Now what is the reference variable? Reference or the variable name as a label attached to the variable's location in memory, that is another name given to a variable location memory. Reference second label, we can say it is a second label attached to that the same memory location. So two variables names are given to one memory location, that alternate name is a reference variable. So accessing the content of the variable through the either the original variable name or the reference variable. We can access the variable name, original variable name, or we can access through the reference variable name. So what is the syntax for this reference variable? Data type ampersand reference name is equal to the variable name, actual variable or original variable name. So again, just this is a referencing variable which already their existing variable memory location is allocated for that existing variable, but we are giving it another name. So this type of reference variable can be used in the pointers also, pointers memory accessing. Okay, so for example, if int I is equal to 17, so I is nothing but a original variable I is equal to 17, in that we are putting the value 17. So memory is allocated for the variable I, and the value 17 is put inside that variable. Okay, so we can declare reference variable for I as follows. How? So giving the data type integer, then ampersand R equal to I. Now I is the original, so we are just referencing the same memory location which is referenced by I, and the value is putting 17 in that. So now we are pointing by a reference variable R, ampersand R. Okay, and this is declaration as a reference variable. So R is now a integer reference initialized to the I variable. Okay, so R is an integer reference, is a integer reference. Similarly, integer we can have the references for the float value, for the character value, for the double value. Okay, so we can have the different type of references according to their data type. So one example is putting for the reference. So hash include IUStream, then main method. Main method is having int I double D. Now declaring the reference variable R, then declaring the reference variable for double, ampersand S is equal to D, then I is equal to 5, defining now allocating the value for the integer I 5, and putting the value of I, C out, similarly C out the value of reference R, then D is equal to, because it is D is type of double, so the 11, this 11.7 is given, then C out value of D, and again the value of reference value. So you can see what is the output for this. Value of I is 5. Similarly, the value of I reference, that is R value, is also 5. Then value of D is 11.7, and the value of D reference, that is the value for S, is equal to also 11.7. So this is a reference variable. This is a reference variable. Similarly, we can have the things like what are the different output operator we have used here. Output operators, statement is cout, then that particular see after cout the operator is used predefined that represent the standard output stream in C++. A stream is an abstraction that refers to the flow of data. Here the standard output stream or device represent the screen, our screen. So whatever is the possible, it redirects the output to the our screen, right? So you will get, if you take this example and you write this and compile this code, you will get this output, right? So mentioning this, then what are the different types of comments in C++? Program comments, it gives the more information about what you have written or what author has written. So comment in C++, new symbol for the comment slash double slash is introduced. Comments may starts with a double slash symbol and terminate at the end of the line, and comment may start anywhere in a line, and whatever follows the symbol is ignored. Note that there is no closing symbol for it. Okay, so for the C++ supports a single line as well as multi-line comments. All characters available inside any comments are ignored by the C++ compiler. They are not executable statements, so just they have been ignored by the compiler. So we can have the two types of comment. Okay, so one is the single line, another is the multi-line comments. So single line comment is given by slash star, right? Single line comments are given by slash star, and multi-line are given by double double this one, double brace, double lines. Okay, so this is single line comment, starts with slash star and end with star slash, right? And this one is, okay, this one is single line comments, and a comment for the one line comment is given by double slash. One line comment is given by double slash, extending to the end of the line. And then we can use it anywhere in the program. Anywhere in the program. So, just like in this example, we have written this double line prints hello world here. So, it is not countable by the compiler because it is a comment. Okay, so whatever you are writing this double line, after that this is ignored by the compiler. Okay, so this is only a executable part is hash include iostream main function, then cout and hello world in double quotes, then semicolon, then return 0 and closing brace. Okay, this is what your uh, single line comment and double line comment. Single line comment is used like this, and double line comment is used like this. Okay, so this much is there introduction to the C++ language, and we have started basic things, that is basic data types, and how we can write a simple example using the main method inside a main, using the hash include iostream, that is the first statement, and then the main method, and inside that main method we just declare whatever the variables we want. We have seen the local variables, we have seen the global variables. Similarly, we have seen the comments, single line comment, multiple line comments. Okay, and we have used the output operator. Okay, output operator are cout and shift operator, that is a bitwise left shift operator we have used here. Okay, so this is what similar to the C language printf function is there. Okay, so same way the printf function is used in C language, we are using the cout statement in C++. So whatever the cout statement or cout is actually used along with the insertion or put to operator. That operator is called as this operator is called as insertion or put to operator. Okay, insertion or put to operator. So we can have this for showing the variable value towards this, whatever the value or the contents are there, towards showing the output it will use cout and this operator. Okay, so right now we'll just conclude this lecture.